So today's lesson is pretty important. Basically, I'm going to try to tie all the missing knots together. If you went to the homework on 3.2, you might have been a little discouraged at some of the questions that maybe you didn't know how to attack. Probably an abnormal amount, and I want to say I apologize because we're a little bit behind on that. Again, I'm not stressing over that, but because I haven't hit on just a few little things, it provided some minor gaps that allowed you not to answer it. Okay, because that was on me and not on you. Feel free, turn that in by tomorrow. Anytime by tomorrow is okay by me. And if you have questions tonight, ask me on the podcast. We'll go through homework questions as well. Okay. The review. Okay. Tell you what. Here's what we'll do. I'm just thinking about this, and I think I'm going to change it here. The review. I'm going to require you to do the multiple choice because of my bust and because some of you are playing catch up on the homework. I want the homework to be really good, and so because of that, you are not required to do the free response questions on the review. So just the multiple choice, because I think that will be beneficial. I'll still do that off the multiple choice section. I'll still do on the study session tonight at 8, but the free response you do not have to do on the review. Do you feel better on that? That way we don't have to feel overwhelmed. Do this, again, do the homework, because that's going to be a good response, good help there, and then the multiple choice, okay?
As kind of like a little bit of help for like our grades, if we do the effort, can you get points for that or no?
Well, you can, absolutely. I'll tell you what, if you do that, I may be able to give you like an extra point.
Okay.
It won't be a ton, but if I give you one extra point and it allows you to get one more rep in, I'm good with doing that, okay?
That's the whole point.
So,
Yeah.
that's good. That's fine by me. So is that fair? If you do it, it's extra. If you don't do it, that's okay. It won't count against you. Okay? All right. So with that being said, let me go over a couple of things today. Today's lesson, we're going to do hit kind of a hodgepodge of things. I told that couple. Is it hodgepodge?
Why is she laughing?
Hodgepodge?
Is it
She
funny?
laughs at me. She laughs at me. Okay. So here's what we're going to look at today. I was talking to Shane. I was talking to Chris. A couple of you, Jacqueline, I know. A couple people are still confused with how do we interpret. So here's what you need to know. For the test tomorrow or Thursday, the one thing that I'm most concerned with when looking at the Monopoly activity is, and by the way, I give you full credit regardless, but there was a lot of missing links with writing in context for a couple of things. You want to probably get this down, okay? Now, again, you need to just kind of go back to your notes. Standard deviation, which is S, slope, y-intercept, there we go, and R squared, and remember DOFs with scatter plots, okay? There's a lot of missing links there. I think it's more just reviewing. I could go back over that information. I just think it's you just looking at it, looking through it, and going over it. And I think that will cover a lot of it, okay? Now, with that being said, let's quickly go over two of them. I want to make sure I hit on it, especially R squared. Standard deviation, remind me what that means again?
The average distance from the mean.
Average distance from the mean. Good, Chloe. When we refer to a scatter plot, it's the same thing, just shifted, right? Do you know what it would be with the scatter plot for standard deviation? Yeah, that'd be good, Alex. So it would be the average distance from my least squared regression line. So the average distance, each point is from the least squared regression line. If you look at this is what it's saying. The actual y, whatever the context is typically whatever the S of x is away from the number predicted by the LSRL. Really, that's what we're saying, right? I mean, it's just shifted just a little bit. But we're saying the actual is whatever it is away from the number predicted by my least squared regression line, okay? I feel like we're good here, no? No? Are we not good? I feel like this is better than this.
Good.
Yeah.
Right? This is tough? Okay.
I don't get, it'll, on the homework it gave us a bunch of number values and then it was create an LSRL line.
Yeah.
Is it this one?
The first response.
I think this is the first one, right?
Yeah.
Okay, so let's do it. Could we just talk through it?
Yes.
Again, I don't have time to actually do the full thing with you, but could you just take some notes as we go through it? Are you good with that? For those that did it, I might ask you, and we could get some tickets for you from that for doing it and knowing what we're doing. Does anyone know it says, is this line appropriate for the model for the use of this data? Jaden, what'd you say?
I said yes, because
Yeah.
the equal amount of the top dots and the bottom dots is like pretty fair, so when that's happening, it's like a good thing.
Perfect. Couple things to note. Make sure you state context once. Make sure you state, what else, Chris, on this did we say? Number one?
You said context, you said make sure you, like, over one, so make sure you, like, state the correlation, like, the relationship.
Yeah, so this is the residual plot one, right?
Oh,
This is not the slope yet. So when we look at the residual, that means there's no what? Yeah, that's what we need to say, right? No pattern indicates that an LSRL model is good. We want that. A pattern would be no good, no bueno. Okay, got me? Remember that? But a scattered one, we need to say it's has no pattern, meaning that we can use an LSRL model. Okay, no pattern, use LSRL. Again, I'm just putting notes down. You need to put more than this, but just so you got that information. Also, what type of plot is this? Residual.
So make sure you do
Plot.
it in the residual and not like a LSRL.
Yep, that's right. In order to state this, we can't just say, oh, it looks kind of close. No, you have to say residual plot. It's no pattern, therefore we can use the LSRL. Okay? Is this helping y'all?
Yes.
Okay, good. Okay. Couple things with here you need to know. This is called a what?
Yes.
Like this whole thing.
Oh, a summary? A summary?
What would you say?
Mini-tab.
Good, yeah, good, Jacqueline. A mini tab, okay? Now, I will tell you, you'll have one of these tomorrow. You need to know how to get the information from it, okay? And again, once we go over it once, I think you'll be okay. So this, over here, here, and here, you do not need for this specific unit, okay? It's just too much information for where we're going, okay, for this unit. Now, you'll see a couple other things. There is no R squared value, but sometimes they'll give it to you. So just be familiar with the fact that they'll put it there. So sometimes you'll need to use it. S is standard deviation, right? The average distance each point is from my least squared regression line, right? Or my actual to my predicted, right, would be an average distance of 33.43. Yeah.
Does S versus this one mean something different?
They both stand for the standard deviation. That's all you need to know right now.
Okay.
If you just know that, you're good. The other stuff we'll get to later. Like the difference between them where you'll see it.
Yeah, okay.
So yeah, if you just know that, you're okay. Over here, this is the least squared regression line right there. Okay, that little column, the constant or coefficient column. This is my what?
Constant y-intercept.
Good, constant, which is by itself, meaning y-intercept, okay? Good. And this would mean my slope, okay? It's always the one that's second with the variable. If you're questioning that, that's how we determine where that would be, okay? Now I'm guessing, based off that, you could probably answer what is the value of the slope and interpret it, right? Now that you can. Same thing with y-intercept and interpreting it. Real quick, what is the predicted number of commercial aircrafts flying in 1992? Well, the distance from 92 to 90 would be what? 2, good. So x would be equal to 2, and if I predict, then how do I predict again?
You plug it into the least squared.
Yeah, plug it in, right? Plug it in. Sponsored by Glade. Okay, so once we, some of you got that. Never mind, plug it in. Never mind, forget it. All right, forget it. So we use this equation and plug 2 in for my equation to get out y hat or y predicted. Okay? Brianna? I will be honest with you, this is very, very good to review for the test tomorrow or Thursday.
So it's gonna have like a mini tab and then it's gonna have.
I would say it might be 2 separate ones. Maybe one is a mini tab and you have to answer stuff about it. Maybe one's a residual plot.
So just maybe.
I would just say this is a really good one. This is very, very thorough. Chris was laughing, or I was laughing at Chris' comment. He's like, there's like 10 questions in this. It's true, okay? But this is really, really good. Know this stuff, okay? Because I'm not trying to trick you on these FRQs for this test. It's really just, hey, what's the slope? Interpret the slope. What's the y-intercept? Interpret it. How do you predict? Plug it in. Residual plot. Stuff like that would be really good to look at for the going forward there. Okay. All right, we good on that?
Yes.
Rocking. Cool. And Chris, on that last one, I know we were talking, the actual one, we talked about going backwards. That's E. So, anyway, we're good. Okay,
Wait, what do you mean going back? Oh,
me and him were talking earlier because when we go here, just so you're aware, it says in 1992, which is x equals 2.
right,
What is the residual of this?
40.
40 meaning it's 40 above my LSRL. Got me? So my residual would be 40. My predicted would be what I would get when I plug in. I can find my actual by going backwards in the A minus P equals residual forms. You see what I'm saying?
A minus. Oh, actual minus.
predicted. Yeah. Cool. Hey, are we good on that?
Wait, so 40 is the actual or predicted?
No, it's R.
40 is the residual. Because this is a residual plot right here? Excellent. Okay, does that help with some of the questions on the homework? All right, good, because there's one more. I know that there was number 61? 61? Okay. Let's do this last one, and then I'm going to have you do something and have me shut up, okay? All right, so on the test on Thursday, there are 2 formulas that you need to know, okay? These formulas I'm going to put up on the board, but you also will have them on your formula sheet on the AP exam. So I'll give those to you on Thursday, okay? Literally, this is what it will ask you. What is the slope or what is the y-intercept, okay? And they will give you all of the information. So the R is the correlation, the S of y is the standard deviation of y, and the S of x is the standard deviation of x. So they'll give you these 3 and they'll say, hey, find the slope. So all you need to do is plug it in, and there you are for the slope for B, okay? Now, the difference with y, with the line over it, that's the mean of the y data, okay? And this is the mean of the x data. And then the B would be the slope. So to get the y-intercept, it would be A equals whatever the mean is of y minus the slope times the mean of x. And I'll literally plug it in. So if you go back to that homework question, numbers, I think it's 61, y'all. I think that's right. 61 here. Look what they gave you, and I think this will help you. It says, here's the mean, here's the standard deviation, here's the mean, here's the standard deviation, here's the R. So when it says find the least squared regression line, you find the slope first by plugging values in, right? And then once you find the slope, you plug it into the y-intercept to get that one, and there you are, you got your 2 for your least squared regression line, okay?
Wait,
Is that on our formula
Say that
sheet?
again.
Did you work it out?
Yes, can I be quick?
Yeah.
Can I be quick? Cool. All right, so if I did this here, so we have B is equal to R times S of y over S of x, right? It says here, where does it say that? For predicting a husband's height from his wife's. So the wife's is the x or y? X. Y hat would be the male's, okay? So the standard deviation of y is the standard deviation of the male's, which was 2.7, okay? And the female's was 2.5. R would be 0.5, good. And when you plug that in, that's my slope, which was, I think Chris and I found it was like 0.54. Okay, perfect. There's that. The next one is, you have to remind me, I think it's B is equal to the mean of y minus the slope times x mean. Well, how do I find that? I plug in what the mean of x is, right? So this would be 64 point, oh, I'm sorry, hold up. The y would be 68.5 minus 0.54 times the mean of 64.5 for the woman's side. And once I get that, that would be my y-intercept, which would be, nice. Good, Catherine. Did you have this done already?
Yeah, I got it first one, but I didn't.
Did you really? Good stuff. Nicely done. So once I have the slope and the y-intercept, there's my least squared regression line, right? Does that make sense, Brianna? Do you get how that would be my least squared regression line?
I see that it would,
Yes? Okay. Tell you what, if you're still struggling, tell me tonight. Say, Coach, could we do another one like that? And we'll do one again tonight. And specifically on a multiple choice, because that's where you're going to see this, is there's one, I think, on the multiple choice for the test. You just need to be familiar with, okay? I'll give you these equations tomorrow. You'll get those.
That's what I was like worried about, just like the equations.
Don't memorize that. Yeah, don't memorize that. Put your efforts in interpreting stuff. How do I interpret it? Rather than formula stuff, that's not as necessary. Does that make sense? Okay. Cool. We went through that. We're good. I'm just hitting notes. Okay, here's what I need. All right, we're gonna have a little competition because we need a breather. Okay. With someone next to you or with your group, I want you to answer the 4 multiple or true or false questions behind me. Okay. Everyone you get correct, I will give a ticket per person. So if you get 4 out of 4, you as an individual will get 4 tickets.
Oh.
Okay. Read the question thoroughly though. Okay. 3 minutes. Ready? I'll give you 3 minutes. Go. True or false? I forgot R squared. I need to hit on that.
If you don't know, then we can't have the question. It's just message.
225. Good.
I'm not sure that's
A little tough.
I think it's true, yes.
For the regression.
Y'all got them?
Do we write them down?
Yes. If you could write them down, just T or F on A, B, C, and D. You don't have to write the full thing.
Just to make a regression line, is explanatory.
No.
But is it important for regression to know which one's responded and which one's the response? Regression is
Y'all get y'all down.
No, we're not gonna read these.
Okay. That's okay. We're gonna see in just a second. Get them down. Y'all get them too. I'm not gonna tell you whether they're right or not. We'll do that together. But we got them in. Locked in. These are a little tough. They're a little tricky. I got 2 out of 4. I'm just being honest, because I didn't read the question.
Okay.
Yeah.
I think we.
Should we change?
Wait, he's saying you got 2
Can you beat Coach J 2 out of 4?
Did they beat you?
What's that?
I'm sorry for saying.
Oh, she.
He said,
Wait, Coach James, tell us.
I have not. No, I won't. I'll tell everybody together. I can come and see.
I think it's a red person. I think it's a
Oh, y'all got it?
Oh, yes, we held it all.
Actually, I think it's true.
A high correlation.
Yes.
All right, we'll see. Here we go.
Wait.
Here we go. Together. All right, let the guys put them down. Question number 1. Knowing which variable is explanatory and which is response is important for regression. How many of you say false? How many of you said true? You all would be correct. Nicely done. I'll give right now 4 tickets to someone who can tell me how I could change that question to where it would be false based on what we had actually talked about. Does anyone know? Sarah?
Isn't it knowing which is explanatory and response is necessary for regression?
Well, could we change maybe this word is important for blank that would be make this false? That actually, I got this wrong because I didn't read the question right.
Correlation?
Correlation is correct. Nicely done. If this was correlation, doesn't matter which is X and which is Y. No, we talked about that, right? I think we talked about that. Perfect. Question 2. Correlation and regression lines describe the strength of any scatter plot. How many of you say true? I love peer pressure. How many of you say false? The answer is false.
I told you, Sarah.
Why is it false?
We both agree.
Any, here we go. It's not any scatter plot. It is any, man, I messed up. Linear, there we are. Linear scatter plot. Nicely done.
Really got me.
Correlation and regression are resistant. I got that wrong. Did you say it to me? That's not how I talk.
She said,
Really got me.
Do I talk like that?
No.
Oh no.
it's a little hard.
Ori
See,
says
now I'm
that.
so-
Ori says that.
Can I say this? We are way out. I know we're way behind, but I gotta say this. Every time I go in the drive-thru, they think I'm
Yes,
late.
ma'am.
They do. They're like, yes, ma'am. I'm like, Honda Civic.
You said,
All right, we gotta go. Are they resistant to outliers? I know y'all are roasted. All right, would that be true or yes or no? That'd be false. And the last one, a high correlation means that one variable is causing changes in another variable.
Oh.
The answer is false because we can't say causation. Okay, I am going to give those tickets out. Here's what I need you to do, okay? With your phone, if you got an iPhone, you can actually use your photos camera to get the QR app or QR reader or whatever. It's like a QR reader. So your phone, you just literally go up and scan it. This will pull up this, okay? As I go around and give tickets, let me tell you what I need you to do. You need to put 10 points down on this to where it has a correlation that is close to 0.4. Okay, so the correlation needs to be close to 0.4. So there's got to be 10 points close to 0.4. Go right ahead. So you'll scan that, and then we'll go from there. Who got 3, by the way?
Oh, we
Jump.
I got 3.
Chris, yours are gonna be at 4.
We got 4, yeah.
Oh,
Catherine, you got 3 there?
yeah.
The QR code reader on the
On Snapchat, yeah.
Wait, you can do it on Snapchat?
You can
Yeah.
do it on Snapchat. Yep.
You can do it on your camera app.
Really?
Yeah.
I did not know that. I know.
Alex, genius.
Sarah, how many did you get?
Shazam this QR.
I got 3. No. She's Snapchat.
What are we doing?
scared me.
Scan it.
Michael,
Is 4 8 okay?
No, Michael.
Last night I walked out of the shower and I was like, I thought there was a man in my room.
Your best.
Oh, what?
Me too.
Let me see.
Coach Jay, is 4 8? Well, never mind.
Wait. It's a new update.
Michael, that gives you.
No,
Just start pressing.
How many do we do? 10?
10.
1,
Oh, come to
2,
No.
3, 4.
5.
I really.
Coach Jay, is 0.49? I mean 3.9 okay?
Perfect. If it's close,
Dropped it way off.
0.43, 0.47, mine.
And a 0.39?
It's fine.
How many?
All right, once you get that done, here's what I need you to write down. Next to it, I need you to draw something that looks pretty close to this right in here, okay? So when you draw this, just kind of draw something that looks like this. Draw your dot plot like that there, okay? Draw your least square regression line. This is just in that space right there.
Oh. Wait, is this all our notes or no?
It is. It's 3.2D. It's our final thing. There, I'm gonna pull this up. Make sure I've got it down.
Drop 10 points.
I'm gonna quit and cry.
If you get close, you don't have to get specific.
Is it?
It's a free program too. If you ever want to like just at home, you want to like. Yeah. Sometimes I do that.
I got 36.
College.
Chris got 4.
You got 0.36?
I got
Yeah, you just put 10 dots.
Okay. Now, as you put this down, you should have this dot plot here. Okay. Now backtrack with me. On the Staplet, I need you to hit the following 2. So you should have something that looks like this. Click these 2 boxes here to where you have the least squared regression line and this line. I'll go over this. If you were to take the mean, you know the X bar we were talking about, kind of, sort of? This would be the Y mean, and the up and down would be the X mean. So if I were to go back on here, just put something down, up and down, something side to side. This would be the X mean. This would be the Y mean line.
Wait, mine's weird.
Is yours weird?
My X line, my
That is weird. That's just,
6,
that's just by
7.
happenstance. Yeah, you'll still get what we're looking at here. We're still looking. Just 0.4-ish. If it's around 0.4, you're okay.
I like 0.52.
It's fine. It's fine. Really, I just need it close to that. Otherwise, it could.
Just type it down. Wait,
I'm really struggling
Does that make sense?
You want it to be around
Wait, I
4?
Around. If it's ish, that's fine.
I gotta restart.
3, 6, 7, 8.
Okay, as you're doing that, as you're having fun there, okay? Y'all are having way too much fun with this. This is fun. It's good.
I'm not having
Okay, then-
We should have a game. You can get. Never mind. Never mind. Okay, so note this. All right, really focus. This is not going to take long at all. I want to make sure we do hit it. Right here, this y mean line and x mean line will always fall on the what?
On the X and Y.
It will always fall on my least squared regression line. It will come on my x and y axis.
Wait, what?
But it will always come on the least squared regression line. So this point is actually x mean and y mean. What do I mean? What am I saying? I'm saying if I took the average of my x values, the average of my y values, and plotted that point straight up and down and straight left to right, that it would create this line, and that the lines that intersected that would fall on my least squared regression line. Y'all follow what I'm saying? All right, so with that being said, we are going to do 4 different things, and this is where we're just going to hang. Just kind of chill right here. So with that being said, we're going to do 4 things. The first thing we're going to do is it says put a point to the far right side of this y mean line. So you could do this with me, or you can just watch, whatever kind of floats your boat. The question that I have is, what will happen to my correlation? What will happen to my slope? What will happen to my y-intercept? Now, any thoughts really quick? If I put a point here, would this slope increase or decrease, increase when I put that down?
Decrease.
Be decreased, good. What would happen to my y-intercept? Would you say, Alex?
No, it's the same.
It's constant.
Did you say increase?
Yes.
Did you say increase? I think you're right. Because it's below the least squared regression line, what's going to happen to this line? It's going to go here, meaning that y-intercept is going to increase, and the slope is going to decrease. Just so you can see it, watch. If I did this, oh man. Oh no.
Oh man.
Oh, there we go. There we go.
Whoa.
Come on. Yay!
Whoa.
There we are. So did you see what happened? The slope.
Ole.
There you are. The slope decreased, right? And my y-intercept increased. All right, we get out of here at 2:15, right? 2:25. We're Gucci. We're Gucci. All right. So we're gonna say that the slope decreased. I'll put a D there, or increased for I. And the y-intercept did what? It increased, right? It increased because when we went here, just so you could see it, there it was without it. But when I put it there, look at the y-intercept right over here. Boom, it went up, right? Did y'all see it? So when I put a point on the y mean side, and I put it over here, the slope decreases, and the y-intercept increased. What happened to the correlation?
Decrease.
Good. Correlation decreased. Okay? Hang tight with me. What if we put one on the far left side? So we're going to remove this here. Put one on the far left side. Someone just kind of give me something for some tickets here. What do you think's going to happen? Jaden?
I think that the slope is going to increase and
Okay.
the y-intercept is basically just the exact opposite of what the first one did.
Cool, let's check it out. What would happen to the correlation?
I think the correlation would decrease.
Decrease? Let's check it out. So if we put one here, it decreased, right?
Yeah.
What happened to my y-intercept?
It increased.
Increased. What happened to my slope?
It decreased.
It also decreased. Okay? Correlation decreased because it's not in my pattern, right? So it would push it closer to 0. So when I did that, decrease, slope, decrease, y-intercept, increase. Do y'all see that? If we put it on the far left side of my horizontal line or my y-mean line. Okay? Am I making sense, Brianna?
Yes.
Michael, do you
First of all, that was Shane.
Yeah, she I was like, good night. It's okay, Michael. You can come. It's okay.
Sorry, Mike.
That deserves a ticket for Michael. He's gonna.
You're welcome.
Yes, Michael.
All right, slope. Let's talk about it. Slope did what? It decreased. Y-intercept increased. Correlation decreased.
Did.
Okay. Y'all are awesome. All right, part C. Let's go to that part. We're going to go to the top line now. So we're going to go up and down. All right, let's check this out on the top. When I do this, this is where it changes a little bit.
I don't like change.
I'm nervous.
Oh.
So what happened with the correlation? It decreased, right? That should be expected because it's way away from the rest of my data. What happened to my slope? Stayed the same. We're going to talk about that in a second. What happened to my y-intercept? Increased. Good. So we're going to say increased, the same on the slope, and then the correlation would decrease as well. Okay?
The correlation will always decrease.
It's a good question. Okay, so think about this. Think about this as a seesaw. Okay? All right? So if this right here is my seesaw, if I put pressure to the left and to the right of it, that would change and kind of my slope that's there. But if I increase either up on top of it, in the middle we're talking, up on top or on the bottom, this thing would still stay the same, right? It would just rotate up and down. You see what I'm saying?
Yeah.
Seesaw, so think of a seesaw. I put pressure on one side, it rotates, it'll change the slope. But if I put pressure on top in the center, where it's the point of equilibrium is, and you don't need to know that, but it will change both up and down. Does that make sense?
Wait, but if you put one on the same on the X, but at the bottom, would it
Right
still
here?
make it negative? Or,
This one?
Yeah.
Let's check it out. So if we did this here, right? Slope stays the same, y-intercept decreases, and correlation will decrease, right? So we would say this would stay the same, this will decrease, and the correlation will decrease.
Didn't we, the one we did before just now, wasn't that up here above the LSR one?
Oh, I flip-flopped them. They would actually be, yeah, so if this should be the one, I did the, no, I flip-flopped them, didn't I? I did the above one first, my B. Above here, this one's below. Does that make sense? Or you could just switch these two. So when it's above, the y-intercept increases, correlation will decrease. When it's below, y-intercept and correlation both decrease there. Cool? Are we good?
Yes.
All right. So question. As we look at this, which outlier that we put on there had the biggest impact on the least squared regression line? Someone raised their hand. Let's see if we can talk this through. Which outlier out of the two, above and below or left and right, had the greatest impact on our least squared regression line? Catherine.
Horizontal ones?
So we would say horizontal. And why is that?
Because like it kind of changes everything, but like vertical ones only didn't change slope.
Yeah, it changed the slope, correlation, and y-intercept in some capacity. All right, so I'm having a hard time explaining this next part. Maybe someone can. Someone in the last class did a really good job of it. It has better leverage. Am I making sense by that? Like, if you put it on the left and right, it impacts it more. Think of the seesaw analogy. It has greater leverage. I'll give like some good tickets if someone can explain that a little bit better than I just did. Sometimes y'all can explain it better than I did, or I do. Am I making sense on that?
Yeah. I think I get it.
It just impacts it greater than like the vertical one. Like the horizontal one just does more than the vertical one does. So like it makes a greater impact on the graph.
Yeah, I like that. That's good. That's good, Sarah. Lindsay, you got something too? It's actually really good.
Since the LSRL like is formed based on how the dots are, and they're usually like they show their pattern like horizontally.
Yeah.
Like the line is usually horizontally formed. So if a dot is added on like horizontally, then it'll affect because it changed the line and how it's like formed. But if you add one above or below, it's kind of just like shifting it a little bit.
Yeah.
Like, it's not changing anything about the actual line.
Ooh, that's really good. Yeah, other than the y-intercept, right? It's just
Yeah.
pushing it up and
It's
down.
just changing it, like,
Yeah, I like that. So if I put it left or right, it's like a seesaw, putting more weight on one side or the other, right? And it affects more. So it has greater leverage. Or I always think of force when I think of a seesaw, but I don't know. I hope that, does that make sense, what we're trying to say? All right, good. Good. I think we've got literally the golden nugget. Here we are.
Do it.
The golden nugget. All right, here we go. Number one. All right, here we go. X and Y.
X, Y.
Kristen, were you throwing it at Michael?
Well, I mean, he kind of just hit me in the face.
No, that was Sarah.
Man, we're having some love today. It's good. All right, so when we go through the LSRL, here's our least squared regression line. We remember, again, golden nugget. We have a line that goes here, a line that goes here. The one that's left to right is my
X.
X mean.
y. Y mean. Think about it goes through the y-axis. Y-axis. This one would be x mean because it goes through my x-axis. Think if I would graph x equals whatever my mean was, right? When in algebra, what did you do? You graphed the vertical line from that went through the x-axis.
No, you have the X. You went
Y would be horizontal.
It's like Y equals 4.
Does that make sense? No. No. So this is the y-axis, right? So if I say the mean is 10, then I'm going to go to 10 on my y, and it'll be a horizontal line. Same thing with x, just the opposite. Okay. This point always goes through my what is it? LSRL. Yes. Very good. Michael coming through.
Thank you.
All right, so the LSRL. Number 2, the other thing that you need to know is the slope formula. This is B equals, does anyone know the slope formula?
Yes,
Oh,
R times.
R.
S of y over S of x. Nicely done, okay? Nicely done. Who?
Yes.
Brianna does?
Yeah.
Brianna, I got you on the next one. What's the slope formula, Brianna?
Wait, I got it.
You got
No, I got
it?
it.
You know it? You don't know?
She doesn't. I don't know.
Okay, so this is A equals what?
X bar
Yeah?
minus B
Hold up.
bar.
I don't think.
I mean, no, I'm sorry. I'm sorry. No, I'm sorry. Please.
Go, James.
Hold on, everyone's screaming. Okay, it is Y
Yes?
bar
Yes?
minus B
Yes?
times X.
Bar. Nice. Make sure you know these formulas here, okay? Know these formulas. I will give these to you tomorrow. So technically, Brianna did get the one where it's A plus BX here. All right. So just a heads up on that. Make sure you know that these two relate to what I plug in, right? Cool. I'm nervous. I'm nervous right now. All right. Let's hold on to the ball there. There we go. All right. Questions on that?
I'm always nervous.
Almost throwing the ball.
Well, I think for the test, I was like, if you're nervous, yeah, I'm nervous.
All right, hey, what are y'all most nervous about? Real talk. What are we the most nervous about?
R squared.
R squared?
How did we guess?
Okay, can we talk over that real quick?
Yes.
Okay. R squared, because Shane brought it up too, and I want to make sure we hit on it, okay? R squared will be given to you. You do not have to ever solve for it. Same thing with R. So that's the beauty of this. What I do with it is really what I need you to know. How do I interpret this? R would be the strength of it, right? Just correlation would be either the weak, moderately strong, moderately weak, extremely weak, right? Those would be the things you would say about R. R squared a little bit different. We square the correlation, R, to get R squared. And it produces a percentage. Guys, everyone good so far on that?
Yes.
So when we get to the percentage is how I interpret it. It really is, like I told Shane, a cookie cutter response. You just got to kind of memorize it. You just got to know it. But really, what is R squared? It's the power of this. The higher the number, the better the power of the least squared regression line would be.
You weren't even in the picture.
Why did you say that?
My thumb is in the picture.
Wait, I got you. Ready? There you go.
R squared would be the power, okay? Think about it. If you squared a value, we know that if we square any R, whether it's positive or negative, it will always produce a positive number, right? The question is how powerful is it? The higher it is to 100%, the more powerful the least squared regression line predicts the scatter plot. Does that make sense? Like, the tighter it is, the higher the power, the better the predicting power. That's actually a good, that clicked. I know, that was really good. I podcasted though, so I'll go back. So think about it this way. 72% of the differences in money, or the differences in Y, this is money, so that's why I'm using it. So 72% of the difference in money is explained by my least squared regression line. The higher this is, the better the percent, the better the power the LSR has over the prediction of my y.
So same thing with R. If you have a high percentage on R squared, you have a strong, okay.
Yeah, because you're squaring r, right?
Yeah.
So the higher the r, the better the power will be for r squared, right? It's just another way of kind of coming at it and saying, hey, how strong is this? Well, actually, 72% of the difference in y, whatever y is context-wise, put that in. 72% of the difference in y can be explained by my least squared regression line. Does that make sense? So r squared is power. The higher the percentage, the more powerful the least squared regression line can be used to contain all of my scatter points. Does that make a little bit better sense? I know a couple of you that were shaking your head yes. Hopefully so. We'll do that again tonight if you need it. Okay, Kathy? Have a good day.
I'm so focused now. Thursday. Me too. Same for science.
Wait, when do you have English?
Thursday.
This part is actually I don't think so because
Now I'm calling.
let me see. I think I did it over here.
Don't you dare.
Ours is also really small, so, you know.
Honestly,
Wait,
I can
Christian.
buy letters from like.
Yes,
On
sir.
this one.
Oh my god, we should go together. Yeah.
Oh, wait, can you get the,
Get negative
can you get the writing back?
Because you owe me, you owe me.
That's funny.
So bad. So is this the least squared regression?
Why are they teaching my homework?
No, this is the y-intercept. This is my slope.
As
So
a,
then I have to plug it in as y hat equals 33.67 plus
No!
That's
Oh, I thought it was
the slope. That's
So
the y.
B equals y-intercept?
Again?
Oh
Oh yeah, this is different. So
I
that
hope
was
you get
part A.
syphilis.
Thank you.
Part B, think of it as this. If I come to the
See, I do remember that.
64.5 is my mean.
you said.
If I say it's one
Okay,
standard
look,
deviation
that's fine, you
below
don't
my mean,
It takes her a little time.
and my standard deviation was 2.5,
Jaden, stop.
2.5 subtracted, which is one standard deviation subtracted would be
Oh my god,
62.
Jaden.
Right? But for a male, it'd be 68.5
Where is Sydney?
subtracted by one standard deviation, which was 2.7,
So also small.
and subtract 2.7 from 68.5. That would give me what the height would be, one standard deviation below my mean. Does that help you?
Is my quiz and test makeup, or am I supposed to come here after school today?
That's a good question. There is no test makeup today.
Okay.
So we can do in my class today if you come right away. It
Okay.
shouldn't take too long.
Okay.
You should probably be done in about 15 minutes, Kristen.
Okay.
Cool? Thank you. Thank you. See y'all. See Sarah. See Catherine.
Tonight at 8 o'clock.
8 o'clock. We're going to be rocking tonight. It's going to be fun.
Wild night.
Good. What's up, Devin? Whoa. That is awesome. That is actually perfect. Where's the naked mole rat, wasn't it? Impossible. That's right.
forgot what his name is.
I forgot.
Me too.
Is it Morgan? It's some weird name like
I think you're right. See you, Catherine. Oh man, how's y'all's day been?